The objective of this video is to demonstrate how you can use Digikey to create a simple schematic and pick out components for the schematic. So first we're going to start by going to digikey.com, and if you go up to the resources menu and go to the schema design tool, you'll find a basic schematic entry tool. This is a free tool that you can use to create a schematic. You can download the schematic, you can populate the schematic with actual parts from the Digikey database, and then you can generate a bill of materials. So this is kind of a one-stop shop for a simple way to create a schematic and set of parts for an example design. So I'll click the schema link, and when you load this, you see a basic sheet, which is your schematic workspace. And on the left side here, you have many options for parts that you can add. You can in fact search the Digikey database for specific part numbers. I'm going to just briefly demonstrate how you can click through these links to find different parts. And we're going to go to the schematic symbols library, and here you can find generic symbols for a wide variety of circuit components. So for example, if we go to diodes, we could drag one of these diodes right onto our schematic page. And when you get it onto the page, you're able to edit the reference designator. This is how the schematic symbol is called out on your spreadsheet, or on your bill of materials spreadsheet, as well as in your schematic, of course. You can edit things like the value. You can directly link the Digikey part number for a component into here. What else we have? We can do the same thing with passive components such as capacitors. For example, we could say that this is a 25 volt 100 microfarad part, and if we do this, suddenly the label appears on our schematic page. You can connect components together. There's also a call out for resistors and inductors. There's transformers, and so on. So what I'm going to do now is I'm going to open up a pre-populated schematic page for a single phase rectifier. So this is something that I entered before the beginning of this video, and what I want to demonstrate now is how you can go from these generic parts to actually specific Digikey parts. So let's say that we're going to pick out a capacitor value, or a capacitor. And for this design, let's assume that our rectifier output voltage is 16 volts, and that we followed our dimensioning procedure, and we've determined that we require a 750 microfarad capacitor. So you can see that we've got a generic part in here right now for the capacitor. No data is entered. And so what we're going to do is we're going to go to digikey.com and pick out an actual part to populate this with. So if we go to Digikey, and I should note that you can search directly within this tool, but I find it a little bit more straightforward to use the main Digikey website. And once you're on Digikey, you can directly type into the search box capacitor. And let's say that we're going to use an aluminum electrolytic capacitor. Alright, so now what comes up is a search view where we can filter down our results. So you can see right now we've got 4,843 results, so that's too many to scroll through. And we said that our output voltage is going to be 16 volts, but let's only view capacitors that start at, say, 30 volts. We're picking 30 volts to give us a little bit of margin, a safety factor. If you were to put a 16 volt part in for your 16 volt output, you'd be riding too close to the edge and you're asking for trouble. And let's put a maximum, so we can see that this brings us down to, actually, first off, we start off with 4,843 pages, and if we put a 30 volt minimum in here, we have 82,000 parts. So let's say that we want a maximum of 50 volts. And then for capacitance value, we said we needed 750 microfarads as our capacitor, but really we can take anything above that. So let's put a range of 750 microfarads to 1,000 microfarads. So this is still too many parts to reasonably go through, but for the purposes of this video, let's just scroll down and see if we see something that will immediately work. And indeed we do. Any of these capacitors, we can see a picture of what they look like. They're all through-hole components. We can solder them directly onto a PCB. So they look like good candidates. Let's in fact go with let's go with this third one. So you can see that the top two components have a minimum order quantity of 500, and maybe I only want to build one board. So I'm going to pick the part that has a minimum order quantity of 1. So if I click this, I can pull up and see how much it costs. I can go directly to the data sheet. I can find some pre-populated values that Digikey has entered for us. So it's specified for operation at 120 hertz, which is the the fundamental of the current that we'd have with our rectifier. So 2 times 60 hertz. So let's go and take this part number, and we'll go back to our schematic and enter this in. And we'll note that, let's see what this part was, a 1000 microfarad 50 volt part. And we can see now that this is populated on our sheet. We can see what it looks like, and if we wanted to hide that for some reason, we could uncheck this box, and now it's hidden. We could choose to show the Digikey part number if we wanted. I'm not going to do that. We're indicating that this is going to be included on our BOM, our bill of materials, and that's an important feature of this tool, that it pre-populates a bill of materials for you. So if you were to complete this as, for example, a class assignment, you'd go ahead and figure out values for all of these components. Probably not your load if we didn't specify there being a load resistor. This at this point is a schematic symbol for a connection going off the sheet. Perhaps it's a screw post terminal. So now let's go to BOM, and we can indeed see that our capacitor has been populated with the part that we've entered. And if we had populated the rest of these parts with actual components, we'd see them listed here as well. And we can export this and in fact download an Excel spreadsheet file that will have all this information in it. Another thing to point out is that in our circuit view here, we're able to export our circuit as various options, but if this was a class assignment, for example, you could export it as a PNG and print it out, or a PDF file. Alright, that concludes this video. This is meant to be a simple introduction to get you familiar with a design tool that you may find useful in this class as well as in your own projects.